All right, hey, welcome guys. Let's do lesson 36. This is on page 237. We are going to be multiplying and dividing integers and multiplying and dividing terms. Now the first part, multiplying and dividing integers, is going to totally piggyback on something that we have already done. We're adding and subtracting integers. So we're talking positive and negative numbers, if you recall. So for example, we added -3 and 2, and we really, since those are opposites, we're going to subtract 3 and 2, and that's 1, and we said -3, so that's the answer is going to be -1. Now today we're going to do something a little bit different. So let's take a look at a number line so we can get a good picture of what's going on here. So if this is 0, and we got 1 and 2, 4, 6, we got 2, 4, 6, and so on. If we got all those things, and our problem is 3 times -2, what is their answer going to be? Well, if you think about multiplication is we're going to take -2, and we're going to multiply that 3 times. So we multiply -2 3 times, where we end up going is we started at 0, we're going to go -2 once, twice, 3 times. What do we end up with? We end up with 6, -6 to be precise, -6. That if we can go back to that number line, if I take -6 and I divide that into 3 parts, what do I end up with? I should end up with -2, because each 3 parts, 1 part, 2 parts, 3 parts, was -2 away from each other. And what you need to learn from that is this. There are some relationships that you are going to have to come to terms with. So if I start with a problem that's got different signs, this is division or multiplication, but different signs. My answer, my quotient, if it's dividing, my product, if it's multiplying, my answer is going to be a negative number. If I am working with the same signs, whether it is, and again I'm going to show division, but here, let's do this one again. Let's do that one for this section, and then we can do my answer for this one with same signs, and I got to include 2 more things. Oops, I put positive. How about that? It's very positive. Now we're talking about same signs. Then my answer is going to equal a positive number. So keep that in mind, that when you're doing these things, this is what you're going to end up with. So we can do a whole lot of problems really, really quickly by just knowing that key fact. Okay, what's 10 times 5? You should be saying 50. I really hope you are. And notice that they're the same sign, so my answer is positive 50. What's -10 divided by -5? You should be saying that the answer is 2, and it's positive 2 because both signs have the same sign, so that's positive 2. Now if you multiply positive 10 and -5, well, that's still going to be 50, but it's -50 because I have different signs. 10 divided by -5, the answer is, again, it's 2, but it's -2 because I have different signs. So keep that in mind as you're doing these problems. You can do that with word problems. For example, look on page 238. Example 2 says, every month $25 is automatically deducted excuse me, from Newton's checking account to pay for internet service. That's cheap. Whoa, I want that. Write an expression using integers that shows the effect on Newton's account of 6 months of charges. So what would that be? Well, they're going to take $25 from his account every single month. Man, I still want that internet service. But we're talking about for 6 months, so we're going to multiply that by 6. But we're doing negative 25 because that's what they're taking away. And we're going to do times 6 because that's what we're looking at, 6 months. And 6 times negative 25 is $150, but negative $150 because that's how much money he is actually being deducted. Okay? And when you talk about deducting something, you're talking about negative numbers. And you don't want that in your account, but that's how it goes. Now, let's move into something that's even harder with this. Let's take a look at a few other things. What about this? Negative 5 squared. What does that mean? You know what 5 squared is. That's 5 times 5. But you see there's parentheses there. And your parentheses are going to act like a shield. And you're going to protect that negative number. So what you're going to do is you're going to do negative 5 times negative 5. Well, 5 times 5 is 25, right? These are the same signs. So it's positive 25, just to make that clear. You could do a number like this, negative 2 cubed. Negative 2 times negative 2 times negative 2. Now, I got 3 negatives. So negative 2 times negative 2 equals positive 4, right? So that's going to be positive 4 times negative 2 is my second step. And my next answer is going to be 8, but notice I have different signs. So I end up with negative 8. So keep that in mind, that what you're going to find out is when you're multiplying and you're dividing positive and negative integers, or numbers if you want to think of it that way, but what you are going to find out on those is when you have an even number of signs, negative or positive, but an even number, your answer is going to be a positive integer. If you got opposite signs, if you have an odd number of signs going on, then you're going to end up with, of different signs I should say, you're going to end up with a negative number. So in this case of negative 2 cubed, I have 3 negative numbers. That's an odd number. They're all the same sign, but it's an odd number. So that's going to give me negative 8. So keep that in mind as you're doing these problems as well. The examples, to give you an example of negative 1 to the 5th power. Well, negative 1 to the 5th power, well, 1 times itself, a million times, is still going to be 1. So you know the answer is going to be 1. That's going to be an odd number of negative signs. So you should know that the answer is going to be negative 1. And just like that, negative 1 to the 6th power, that's still going to be 1. And you know that's an even number of negatives. That's going to yield you a positive number. So that's kind of a cool trick. Now later on this year, we're going to do some explanations of just what this equation is. But for today, all I want you to know is that x equals negative 2, and I want to find y. And then we'll do something else. We want to find the value of x squared when it's negative 2. Okay? So we're going to multiply negative 2 times negative 2, that's what x is, and we end up with the answer of 4. Now, x squared equals 9. What two numbers, now another problem, x squared equals 9, what two numbers could x be? Well, 3 squared equals 9, right? And also negative 3 squared equals 9 as well, when we're talking about negative 3 in parentheses. So we have to distinguish between square root and radical, which indicates the principal square root, which is a positive square root of a positive real number. So the square roots of 9 are 3 and negative 3. Okay? But the principal square root is going to be the positive number. So keep that in mind, that when you're doing square roots, that there's also that indication, say the square root of 16 that your answer is, your principal square root answer would be 4, but negative 4 squared, when you're talking about negative 4 in parentheses, also gives a similar response. So I do want you to copy the chart on page 240. Page 240, copy that chart. That chart is what I just talked about in a quick, brief, handy thing combining this lesson and a couple lessons ago. So keep that in mind. There's a little thing about using calculators on page 240 that I'm not going to talk about, but you should. Now, back in lesson 31, we added and subtracted terms. In this lesson, we're going to multiply and divide terms. So let's do something a little bit different. 6x squared times y times negative 2xyz. A lot of stuff going on there. Okay, we can do a lot of stuff to yield an answer for this one. And I can move all my things around. I can write my problem like this. 6 times negative 2, because I can use the commutative and associative property of multiplication to get that. And then I get x squared, because that's x squared, times x times y times z. And all I did was just rearrange everything. Everything's still there. Well, 6 times negative 2 is negative 12. Now let's put all your x's together. I get x to the third power. All my y's, I get y squared. And then my z is all by itself. Now that works the same way with division. 6x squared y divided by negative 2xyz. And again, I'm going to break this down. 2 times 3 times x times y over negative 2 times x times y times z. I'll make my y more clear. And what you can do with that is you can cross some stuff out. That this is going to go away. They don't disappear entirely. They become ones. So you might when I cross them out, I kind of try to make them look like ones. I got an x on the bottom and the x on top I can take away, and a y and another y. What I'm left with is 3x over z. Now keep in mind, this was negative 2 right here. So it's negative 3x over z. So you can definitely do that. You want to make sure that it's preferred to put the negative sign, because it's the whole thing is negative, not just one part of it. So it's preferred to write the negative sign like that. Now one more thing, we could use the distributive property to expand some of this too. We could do this. Okay, that means we're going to multiply 3x times here and here. And when we do that, 3 times 2 is 6. X times x is x squared minus 3x times 4. 3 times 4 is 12, and I can't forget the x. So I have just totally expanded this problem. And if I were to factor out, I'd end up back to where I started. Now the exact same problem, now with a negative number, yields something different. 3 times 2 is 6, but they're opposite signs, so it's negative 6x squared minus, or is it, 4 times 3 is 12x, but I had same signs, so that's really positive 12x. Go ahead and try every other practice problem on page 241, and we'll discuss tomorrow.